Okay, we are on page 15 of additional topics. This should be the last video for additional topics, and it should also finish up the text. We just finished trig on page 14, and we're going to go back to geometry. We're going to look at the distance formula and circles. Then we're going to look at triangles, and then we will be done. Okay, so top of page 15, it says the distance between points A, and we just named A x1, y1, and B x2, y2 is given by, we have AB equals the square root of x2 minus x1 squared plus y2 minus y1 squared. This formula needs to be memorized. There will be a couple probably on the SAT for distance formula. Okay, so I want to go over how the distance formula is derived. So just in case you forget the actual formula, you might be able to derive the formula from a picture. Okay, so let's say this is point A, x1, y1, and this is point B, x2, y2. And we want to know the distance. Okay, so what is the distance between A and B? Okay, so what we're going to do here is we're going to drop the A down to B and then move A to B. Okay, and you can see that this makes a right triangle with the distance D, or AB, being the hypotenuse of the right triangle. Okay, well, we know how to find the hypotenuse of a right triangle. That is leg squared plus leg squared. So we just need to figure out what this leg is and what this leg is. Okay, so let's on our axes go ahead and label these points. X1, this is go over X1, and then this point is up Y1, so you have Y1 here. This one is go over X2 and up Y2. Okay, so this distance here is X2 minus X1. Okay, so if you have a straight line to find the distance between 2 points, you just subtract. So x2 minus x1. Okay, same thing here. You can do, I would probably do y2 minus y1. Okay, just to keep it the same, so x2 minus x1. And we're going to square this because this is a right triangle, so it doesn't matter if you have y1 minus y2 or y2 minus y1. The only reason I used y2 here is because I started with x2 here. Okay, so we have a leg, and the hypotenuse. Okay, so I'm coming over here. I'm going to go ahead and write out the formula for my Pythagorean theorem. So we have leg squared, x2 minus x1 squared, plus the other leg, which is y2 minus y1 squared, equals the distance AB squared. So leg squared plus leg squared equals hypotenuse squared. And we want to solve for AB. So to solve for AB, we just take the square root of both sides. So square root of x2 minus x1 squared plus y2 minus y1 squared, that gives us AB. Okay, so that is where the distance formula comes from. It's just from a right triangle. Okay, examples is find the distance between the points A, 2, 0, and B, 5, 3. Okay. So we'll do the distance AB equals the square root. I'm going to go ahead and name this one x1, y1, and this x2, y2, but you can do it in either order, it doesn't matter. So we want to do x2 minus x1. So 5 minus 2, square that. Plus y2 minus y1, so 3 minus 0, square that. Okay, a really common mistake I see for students is you guys say, okay, the square root and the squares cancel. That is not true. You have to square first, then add, then take the square root. Okay, so the square root does not go away at this step. Okay, so equal to the square root, this would be 3 squared plus 3 squared, which is equal to 9 plus 9, which is equal to square root of 18. Okay, which we can simplify, which we would need to do for the SAT. So that's not square root of 9 times 2, which is 3 square roots of 2. Okay, so there's the distance formula. Next, in bold, we have an equation of a circle with center HK and radius r is x minus h squared plus y minus k squared equals r squared. Okay, again, I'm going to draw another picture here. So this will need to be memorized also. So this is the equation of a circle. We have center HK, radius R. Okay. Again, if you can't remember it, you might be able to still derive it. So let's say I have a circle here. The center is HK. And then we have radius R. So I'm just going to plug in a point here, R. Okay, so this is some random point XY. This is HK, center HK. Okay, so from the center to any point, I could have chose any point along the circle. Okay, we have R, and then I'm just choosing some random point XY. Okay, so we need to have the distance of the radius, okay, is going to be the square root of x minus h squared, so I'm going from this point to this point, or this point to this point. That's going to be the distance of the radius, plus y minus k squared. Okay, notice this is for any point. I could have done this and named it something else. I could have did vw here. Then this would have been v minus h squared plus w minus h squared. Okay, I chose any point here. Okay. Now to solve for the radius, you would square both sides. So I'm going to put a d here just to keep it the same. So this is, square both sides, this would go away. X minus h squared plus y minus k squared. Okay, so that's where the distance formula, the equation of a circle comes from. Okay, so you have radius squared equals x minus h squared plus y minus k squared. Okay, so the equation of the circle comes directly from the distance formula, which came directly from right triangles. Okay, so now using this formula, it says find an equation of a circle with its center at 2, -5, and a radius of 3. Okay, so center is HK, and then the radius is 3R. Okay, so I'm just following this formula here. So we would have x minus h, which is 2, squared, I'm following this formula, plus y minus k, so y minus -5, squared, equals 3 squared. Okay, and we just need to simplify. So we have x minus 2 squared plus, this changes to plus 5 squared equals 9. Okay, so there's our equation of that circle. Okay, top of page 16, it says given the equation of a circle x minus 3 squared plus y plus 4 squared equals 3, find the radius and the center. So above this equation, or I'll do it below, I'm going to go ahead and write out the equation of a circle. So x minus h squared plus y minus k squared equals r squared. Okay, so now you can see h is 3, k would be, okay, it's supposed to be minus, but we have a plus here, so it would be -4. And then r would be square root of 3, because you have to have r squared here. Okay, so the center is hk, so it would be 3 -4, and then the radius is square root of 3. Okay, so go ahead and stop there and complete practice set 8. So practice set 8 has all of your trig on it. There's a little bit of geometry. I think it begins with working with circles. Then it goes into trig, and then we go into the distance formula and equation of a circle. Okay, so you'll stop there, do practice set 8. We're going to continue with this video though. We're just going to go ahead and finish out this additional topics. So the last topic we're going to go over is triangles. So we've looked at right triangles, which is a very specific type of triangle. Okay, but we are also going to be looking at just triangles in general. Okay. So first thing we have to learn for triangles, it says the sum of any two sides of a triangle must be greater than the measure of the third side. Okay, so we have an example. Could a triangle exist with sides 3 centimeters, 4 centimeters, and 6 centimeters? Okay, and then we're going to do one more example. So let's look at this theorem. It says the sum of any two sides of a triangle must be greater than the measure of the third side. So pick any two sides, add them up. As long as that is greater than that third side that you didn't include, then it is a triangle. So let's look at 3, 4, and 6. So let's pick two sides. So let's do 6 and 4. So 6 plus 4 equals 10. Is it greater than the third side? Yes, 3. Let's do 3 and 4. So 3 plus 4 equals 7. Is it greater than the last side? 6. Yes. And then the last one would be 3 and 6. So 3 plus 6 equals 9. Is it greater than the last side, which is 4? Yes. So this would be a triangle. Okay. Now let's look at what about 1, 4, and 6. So let's go ahead and start. So 6 plus 4, that's 10. Is it greater than 1? Yes. What about 1 plus 4? That is 5. Is it greater than 6? No. So it is not greater than 6. So this is not a triangle. Okay, so be careful on the SAT. You'd want to check, make sure it could be a triangle first. Okay, so again, any two sides of a triangle added together must be greater than the third side. Okay, next we're going to do congruent triangle theorems. Okay, so these are theorems that give you exactly the same triangles without actually checking all the angles and all the sides. The first one is side, side, side. So it says if 3 sides of one triangle are congruent, respectively, to 3 sides of a second triangle, then the triangles are congruent. So this says if every single side of a triangle is the same as another triangle, then you have congruent triangles, which makes sense. Okay, so let's say we have two triangles that look like this. Okay, this side is congruent to this side is congruent to this side, and this side is congruent to this side. Okay, that would be side, side, side. These would be congruent triangles. Next example, side, angle, side. It says if 2 sides of a triangle match the 2 sides of another triangle, and then the included angle matches the included angle in the other triangle, then the triangles are congruent. What that included in parentheses means is it has to be inside of the 2 sides. Okay, so for example, if you have a triangle like this, and let me go ahead and draw another one. Okay, so let's say we have this side congruent, this side congruent, this side congruent, this side congruent. Then the included angle has to be congruent here. Okay, so it doesn't matter about the 2 other angles in the last side. Okay, if you have side, angle, side. So side, angle, side. Okay, so the angle has to be inside or included of the 2 sides that are congruent. Okay, number 3, we have angle, side, angle. So if 2 angles in the included side, okay, so this is opposite. So now we have 2 angles in the included side of one triangle are congruent to 2 angles in the included side of another triangle, respectively, then the triangles are congruent. Okay, so just drawing another picture. So let's say we have this angle and this angle, this angle and this angle. Okay, so those are congruent. Then this side in between has to be. Okay, so angle, side, angle, angle, side, angle. And then the last one, angle, angle, side. If 2 angles and an opposite and a side opposite one of these 2 angles of a triangle are congruent to the 2 corresponding angles and the corresponding side in another triangle, then the 2 triangles are congruent. Okay, so just drawing 2 triangles again. Let's say we have this angle and this angle and this angle congruent. Make that like that. Okay, so these 2 are congruent, these 2 are congruent. Then it says one side opposite of one of the congruent angles. So it either could be this side or this side, which I'm going to pick this one. Okay, so you have angle, angle, side, angle, angle, side. Okay, so those are the theorems. You need to memorize these 4 theorems. So side, 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 angle, 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 side. Okay, on to page 18. It might be easier to memorize the ones that do not work. So ASS does not work and AAA does not work. So ASS would mean angle, side, side. So you have 2 sides and an angle that's not included. And angle, angle, angle. So if you're just given 3 angles, that does not work. Okay. So 3 angles doesn't give you congruent triangles because you could have just like a scaled up triangle. So here is an example. These 2 triangles may have angle, angle, angle. Okay, but they're clearly not congruent because you've scaled up. Example, it says show that the given pairs of triangles are congruent. So we're just going to do some examples here. Let's do one like this. So let's say this is 3 centimeters, this is 2 centimeters, this is, let's do 4 centimeters, not drawn to scale. Let's say this is 30 millimeters, 20 millimeters, and 40 millimeters. Okay, so we only have sides here, so we have to check and see if this is side, side, side. So are the corresponding angles congruent? We have meters and centimeters here. Okay, so we would do the King Henry died Monday drinking chocolate milk. This is decameter, this is decimeter. Okay, so from centimeters to meters, let's actually go meters to centimeters. You move the decimal one place to the left. So here we move it one place to the left, here one place to the left, here one place to the left. So this would be 2 centimeters, 4 centimeters, and 3 centimeters. So you can see this is by side, side, side. So side, side, side gives you that they're congruent. Okay, let's do another one. Let's do 2 right triangles. Let's flip them so they look different. Okay, so you have a right angle here, right angle here. Let's say that we have 48 degrees here, 48 degrees here, and we're given that the hypotenuse is 7 meters. Okay, are these two congruent? So we have angle, angle, side, angle, angle, side. Okay, so does angle, angle, side work? Yes, it does. So these would be congruent by angle, angle, side. Okay, let's do another one. Say we have this picture. Okay, and we're given that this angle is congruent to this angle is congruent to this angle. Okay, so this picture's a little different because we don't have 2 separate triangles, which I'm going to make that look a little better. Okay, so we have a triangle here, and we have a triangle here. And notice that the triangles share a side. Okay, so that side is congruent, okay, in both triangles. If you would have split this up, this side is congruent because it shares that side. Okay, so we have angle, side, angle, and angle, side, angle. Okay, so this one would be congruent by angle, side, angle. Okay, let's do one more. Let's say we have 2 parallel lines. So we'll call this L and M, and we'll say that L is parallel to M. And let's just do this picture. So we're looking at these 2 triangles here. Okay, this is all we're given. Okay, so now we have that these are parallel lines. This line here would be a transversal. So remember from our geometry from the beginning of this section, we have corresponding angles, interior, alternate exterior, and vertical angles are all congruent. Okay, so looking at these 2 triangles, we can get some angles here that would work. Okay, so we have alternate interior. So I'm looking at, I'm trying to figure out which one I should do first. This transversal going through these parallel lines. Okay, so this angle would be congruent to this angle by alternate interior. So this transversal going through these 2 parallel lines, okay, gives us alternate interior here. Okay, now this transversal going through these 2 parallel lines would give us alternate interior here. Okay, now also these triangles share a side. So we have angle, side, angle, angle, side, angle for two triangles. Okay, so we could do angle, side, angle for this. We also need that these, which I should have wrote this down. Let's name this A and B. So we have A is parallel to B. Okay, so we have angle, side, angle, which works. Okay, so those are just some examples for your theorems. The main thing is this isn't too difficult of stuff, but the main thing is to just make sure you know that these two do not work. So there might be some questions on that on the SAT, but for the most part, this is pretty simple because you're given all of this stuff is congruent. There's not much more work to that. Okay, page 19. We're going to do our last concept for the text, and this is on similarity. It says when two shapes are the same, but the sizes are altered, they are similar. And we denote similar by this sign here. It says that is, corresponding angle measures are the same, and corresponding sides are proportional. Okay, so for example, this just doesn't have to be triangles. We could have a rectangle like this and a rectangle like this. Okay, so we have angles that are the same. Okay, and the sides need to be proportional. So this would maybe go to 6. Okay, so 2 times 3 gives us 6. So if this was 3, we would need 3 times 3 to give us 9. Okay, so the sides are proportional. Okay, we scaled up by a factor of 3. Okay, definition, the ratio of corresponding side lengths is a scale factor. This tells you how the sides have changed. Okay, so scale factor here would be 3, going from here to here. Okay, it says if two shapes are similar, it does not matter what side you choose, they should all be the same scale factor. Okay, so if we did, let's just do a triangle. Let's say we have 2, 3, and 4. Okay, and let's scale up by 2. So let's have the scale factor be 2. Then we need to scale up 2 for each one. So 2 times 2 is 4, 3 times 3 is 6. I'm sorry, 3 times 2 is 6, and 4 times 2 is 8. Okay, now we're going to see our tests for similarity. This is for triangles only. Okay, so what we just did, we did congruency theorems. So this test, those theorems are all tests for if two triangles are congruent. For these, it is if two triangles are similar. Okay, so for similarity, that means that the angles are the same, but the sides have to be proportional. Okay, so number 1, we have side, side, sides. Okay, so that means all 3 sides are not the same, they're proportional. Because if they were the same, we'd have congruent. For side, angle, side, you have 2 sides are proportional, and then included angle is congruent. So the angles have to be the same. And then angle, angle, so that just means 2 angles congruent. Okay, so notice I don't care about any sides here. This picture I drew on the previous page, okay, you have 2 angles congruent, which forces the third angle to be congruent because it has to add up to 180. These would be similar triangles. Okay, example says which of the pairs are similar? So let's say we have this one, and let's draw it opposite this triangle. I'm going to say this angle is 36 degrees. That doesn't look right. Looks more like a 90-degree angle, so we'll do like 85 degrees. Let's say this is 9 centimeters and this is 5 centimeters. Okay, I'm going to say that this is 3 centimeters, and then this angle is 85 degrees, and this is 5/3 centimeters. Okay, so if this works, it looks like we would have side, angle, side. Okay, but we have to check, we have a congruent included angle. Okay, but we have to make sure the sides are proportional. Okay, so from 9 to 3, we had a scale factor of 3. And then 5 to 5/3. It looks like that would also be 3. reduced to 3. Yes. Yes, that works. Okay, so that is just so you can see the work. So I did this in my head. So 5 over 1 divided by 5/3. Remember to flip. That's 3. Okay, so this is yes by side, angle, side. So the scale factor was 3 going from small to large. Let's do another one. Let's say we have this triangle and this triangle. We have a right here, and then this angle is 35 degrees, and this angle is 35 degrees. Okay, so if this were similar, okay, it would be by angle, angle. So you have to check, are 2 angles congruent? Yes. Which actually means that 3 angles are congruent because they all have to add up to 180. So the last one, it forces the last one. So this would be angle, angle. This is yes by angle, angle. Okay, and we don't have a scale factor. Here we had a scale factor. Okay, but we don't for this one. We didn't have any sides. Okay, let's do one more. So 2 sets of triangles. Okay, so let's say this triangle, this is not drawn to scale. So let's say this is 0.4 inches, this is 0.1 inches, and this is 0.6 inches. Over here, let's say this is 0.5 inches, this is 3 inches, and this is 2 inches. Okay, so we need to check. It's probably easiest to check this small side first because we can see that those go together. Okay, so we'll do 0.5 over 0.1, which gives us a scale factor of 5, it looks like. Okay, so now we need to figure out what side goes with what side. Okay, so we're going to have the smallest out of these 2 longer ones, 0.4, would look at 2. Okay, so 2 would go with the 0.4, 3 would go with the 0.6. I'm going to keep it like this, so I did the large over the small. So this would be 2 over 0.4. Okay, so 2 divided by 0.4. I got 5 here, so we need to check one more. All 3 of them have to be proportional. 3 divided by 0.6 is also 5. Okay, so all of these are proportional. So this would be yes by side, side, side. Okay, so that gives us an example of each one of those. Okay, we have one more example, so this will be an application of similarity. It says a tree 30 feet tall casts a shadow that is 12 feet long. Angela is 5 feet tall. How long is Angela's shadow? Okay, so let's draw the tree and the shadow. So the tree is 30 feet, and it casts a shadow, so the shadow would be down here. That's 12 feet, which I'm going to draw this more to scale. Okay, so notice that we have a right triangle here. Okay, now we have that Angela is 5 feet tall, and we have some shadow here. Okay, so we want to know what this shadow is, x. We have a right here. Okay, so since the sun is facing the same, it says it's at the same time of the day, this should be similar. Okay, so we have that 30 is proportional to 5, so then 12 would need to be proportional to x. Okay, so let's go ahead and figure out what our proportion is. So 30 over 5 is 6. So that means that 12 over x needs to be 6 also. Okay, so cross multiply, that's 12 equals 6x, so x would be 2, and that is in feet. Okay, so there's an application of similarity. There will probably be applications of similarity, maybe 1 or 2 on the SAT. It's going to be more like this rather than these examples that I did down here. Okay, so go ahead and stop there and do practice set 9. So this last practice set has basically just the triangles, I believe, on this one. So mostly applications on triangles. Okay, and then that will be the last problem set of this test.